Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Everybody, my name is Lee Grant, and I am a technical solutions professional in the high-performance computing group at Microsoft. How many folks knew that Microsoft has a high-performance solution? Well, we pretty much all do. Well, about 3 or 4 years ago, we came out with based on Server 2003. We called it the Compute Cluster Server, CCS. And now, recently, it was in September, we launched our version based on Windows Server 2008, and it's called Windows Server High Performance Computing 2008, High Performance Computing Edition. And that's what I'll be talking about today. I don't know, would you guys want to interrupt me with questions, or do you want to save your questions for the end? Maybe it'd probably be better to save them for the end, then we can pass around the microphone. So let's get started. So one of the things that we've been talking about and thinking about at Microsoft is, instead of high performance computing, let's think about high productivity computing. And this is something that came from the Executive Office of the President, the Office of Science and Technology. And this is a quote from them. They want to make high-end computing easier and more productive to use. Emphasis should be placed on time to solution, the major metric of value to high-end computing users. A common software environment for scientific computation encompassing desktop to high-end systems will enhance productivity gains by promoting ease of use and manageability of systems. Well, that certainly works out really well for Microsoft, because we pretty much have the desktop. You know, we own that. I'm sure all of you use Excel or use Word to produce your reports, produce your papers, etc. So as far as the infrastructure of your organization, it would be nice to have a common platform. So instead of doing all of your work in, let's say, a Linux system or a UNIX system, and then moving that data over to a Windows desktop to compile your reports, compile your spreadsheets, etc. Now we basically have a situation where the supporting personnel you have can support both your desktop and your servers. So, and kind of if we think about the history of high performance computing and how much it costs per gigaflop or per processing unit. If you think about it, in 1991, a Cray, you got 10 gigaflops, it cost $40 million. 7 years later, you could get a Sun, get 10 gigaflops for $1 million, and that was a 40-time drop. Now, with a Windows server system, you can get 10 gigaflops for less than $4,000. So that's quite a bit of a drop-off. And it becomes now something that not only can the large organizations afford this, but certainly, small organizations can now basically have a supercomputer under their desk. So one of the things that's important about doing high performance computing is dealing with our data. And the data, you're familiar with the data pipeline. You're gathering data, you're browsing it, you got scientific exploration, you have domain-specific analysis that you do, and then you have the scientific output. All of this pipeline, basically, this is kind of how the data gets formed, and eventually, if you see down at the bottom, you're producing a paper. So, as far as what's going on currently in software or in hardware development, we're kind of running into a physics problem right now. How many of you have still use single core systems? But if you wanted to go out right now and buy a single core system, you probably couldn't find one. You know, they're pretty much all multiple cores, and the main reason for that is because I don't have this particular slide in this deck, but the Pentium chip, when it's running at 100%, the heat value on it is hotter than the sun when it gets over a certain gigahertz rating. So we certainly can't make faster and faster chips anymore. We're running up against a physical limitation. So one of the nice things that we can do now, though, is we can have more and more cores. So we can lock our speed, but then scale out by having multiple processing cores per chip. And right now you can go out to Best Buy and buy yourself a quad core system. I imagine next year you'll be able to buy yourself an 8 core. And if you need a server, you can get multiple sockets. And that's kind of where we're looking right now, is that you can have multiple two socket machines with 4 cores, so you can have an 8 core box. Put 100 of those, now you've got 800 cores. And I'll give you an example. In our New York office, in our MTC, we have a portable cluster from Nortec that has 128 cores in it. And it's maybe 19, 20 inches high, about 30 inches wide, on wheels. All it takes is 220 amp circuits, so it's not like it requires a huge amount of power, and it doesn't require any specialized cooling. So that's a very nice system. And in fact, they can even build one that looks like, I saw their system at the supercomputing in their booth. They have one that looks like it sits inside of a cabinet that would be in your office, and it's quiet. It's set up. It's got baffles in it so that it's quiet. It was a pretty impressive system. So right now we're in a case where we're not getting faster chips. We're just getting chips with more processing power on them. But what happens here, though? How many of you do multi-threaded development now? Is it easy to do? Well, to a certain extent. What was that?
My background is
embedded engineering. Okay, all right. He doesn't count. But to do multi-threaded, multi-processing programming is not easy. And we're going to talk a little later about some tools that Microsoft's providing to make that easier for the developer. How many here are developers? Okay, so do any of you use Visual Studio now? So, well, we can we'll talk about some of the add-ins that are going to be coming later on that will help make multi-threaded development easier. So, what's our vision? Well, one of the important ones is to reduce complexity. I mean, right now, if you need to administer a 100-node or a 1,000-node cluster, it's not something that one person can do, and it's probably not something that really a group of people could do. It becomes somewhat difficult. So we want to ease the deployment of large-scale clusters, and what we mean by that is from the bare metal up through the OS. And we want to simplify management of it of all scale. So we want to be able to have a single point where you can go in, look at a cluster manager, and see what's going on in your cluster. Bring nodes offline, online. If you need to do some maintenance, you can bring a node offline. Go off and do the maintenance. Swap a drive if you have to, et cetera, and keep going. And if you already have a Windows, who here has an Active Directory system where they work, where they get email through Exchange and yeah.
because you might have
Okay, well, the comment was, and I have to repeat the comment because this is being recorded. The comment was that this is also an issue because what happens if you're not in charge of your existing domain? So if you're a corporate backbone or a university backbone that's run by the corporation or the university, not by the individual work group. And yes, that becomes an issue, but as long as you have single sign-on, you're going to be fine because you'll use your domain credentials with your cluster. You should be okay.
Yeah, but my point is that you need to be able to add plus computers to the domain, modify the parameters in the domain, set up fixie somewhere
Well,
in the domain, and
you don't necessarily have to have. The cluster doesn't necessarily have to be part of the domain. Only the head node needs to be, and the rest of it can be on a private network.
yeah, but then you have to set up your own domain.
Yes, but that's not rocket science.
Yeah, I know, but this is
But-
kind of weak point there because it still requires too much interaction with the other guys that have much less time.
True.
And finally, the only solution is to push on them to get certain privileges, and then they go away, and I can do whatever I want. But it's not always possible everywhere.
Okay, yeah, that's true. Good point. Sorry, what?
There's not just one point.
Yes.
One pushes down. You just get a copy of what you need.
Yeah.
You do whatever else you need.
Well, that's. I mean, the thing is, as long as you're able to you have the freedom to do what you want to do external from a domain that may be locked down, you'll be fine. So, in addition to reducing complexity, we want to make high-performance computing more mainstream. So, we want to take it out of the purview of what I like to call in quotes the priesthood, where you have these guys in lab coats that are in the back room, manipulating their systems. So we need to do traditional supercomputing. We need to address what cross-industry computational trends are. And then we also need to be able to have non-technical users harness the power of high-performance computing. So in a lot of ways, that's where the developer comes in, where the developer can create products that make it easier for the layperson to use it. And the example I like to use is somebody who logs into a financial institution to look at their 401k and get reports back through Excel. And in a lot of ways, if they're looking at how they want to invest if they want to look at maybe some sort of a calculation of risk to look at how to invest their money, on the other end, there's probably some sort of a Monte Carlo simulation going on to calculate that risk. And that person that's sitting at their computer at home doesn't know that at the time they're doing high-performance computing. It's happening transparently to them. And last, we certainly want to make it easier to develop for it. And that means easing parallel application. We want to give people a choice of development tools and languages and libraries. And we want to make the universe of developers that can do HPC computing larger. Now, who here, I already asked who uses Visual Studio. Who here does .NET development on Visual Studio? So, I'll go to the embedded guy here because he's obviously the one in the crowd that's going to answer all my questions, not the way I want them answered. Would you say that .NET development is easier than C++ development, traditional C++ development? Okay, all right. Well, that was one of the reasons why the .NET framework was developed. Was Microsoft discovered that writing code was was getting more and more difficult. A lot of people were using Visual Basic, and Visual Basic was limited in what you could do down to the metal of the machine versus C++. And then doing COM development was quite difficult in C++, difficult to maintain. So it just .NET was kind of a way of making it easier, making development faster, and also making support of it better. So you'll see Microsoft has this logo now, HPC++, which is supposed to be highly productive computing. And let's talk a little bit about how all this is how it all sort of fits together. Well, you're all familiar with our applications. We have SharePoint, Excel, SQL Server, Visual Studio. We have the .NET framework there with Windows Communication Foundation, Windows Presentation Foundation, Workflow Foundation, and Card Space. Those are the .NET 3.0 pillars. We'll talk quite a bit more about WCF in a little while. Now, on top of that, we add Windows HPC Server 2008. Now, Windows HPC Server 2008 is essentially Windows Server 2008 with the addition of the HPC pack. Now, the HPC pack has a scheduler and the monitoring tools that allow you to create the cluster. Now, this fits in nicely with an Active Directory system as well as with System Center. You can use System Center to help administer your cluster from the Active Directory domain. But if you don't have access to System Center, you can still do quite a bit, and I'll be showing you some screenshots of some of the things that you can do to keep your cluster behaving properly. But this is to show that your cluster can be integrated with your enterprise infrastructure. Granted that your enterprise infrastructure allows you, the folks on your enterprise infrastructure allow you to do that. And then there's also some system benefits. You get the benefit of Windows Server 2008, which is more secure, a better performing operating system. You also get Hyper-V. Is everybody familiar with Hyper-V here? Anybody familiar with it? Hyper-V is our virtualization technology. So basically, you can create multiple. You can create I have on my laptop. I've installed Windows Server 2008, a dual boot, and I have Hyper-V running, and on an external hard drive I have virtual machines, and I can run a small cluster off my laptop. It's not a real fast cluster, but it's good for testing out things. So in systems management, so we kind of have all these different technologies strung together to help do HPC. We have systems management, job scheduling, MPI, and storage. So we'll start with systems management. One of the goals is to have rapid deployment with our clusters. So I can give you an example. When you're provisioning your cluster, you build your head node. And once you build your head node, you can then build basically a package that gets deployed out to all of your target and all of your compute nodes so that they can be built. And with a limitation of about 200 at a time, and that has to do with the multicasting limitations. You can push out, so I can sit there and I've done this, and I'll show you a little bit in a little while how you can group clusters together. But basically, you can push out, say, go start these 200 nodes from the bare metal. And then once those come up, then you can do 200 more. So it takes about a little over an hour for 200. So if you think about it, you can do a 1,000 node cluster. You can provision a full 1,000 node cluster in under 5 hours. And as far as managing it, you can have we have a cluster manager that I'll show you screenshots of that allow you to see the health of your network. You can look and see. You can have a heat map. Please come on in. We have a heat map that shows you what's going on as far as how your nodes are operating, how their memory usage, etc. You have different parameters you can look at, and you can script things. You can script different functions that you want to do, and it has a similar UI to all the other tools that you get inside an Active Directory enterprise system. So for storage, the Windows HPC Server uses SQL Server as its main store. You get with the product you get you use SQL Express, which for small clusters, 10, 20 nodes is okay.
Why do you think that it's not okay for bigger ones?
For bigger ones, we find that you'll want to use SQL Standard Edition at least, and also you will also, if it's really big, you even want to have it on a separate machine. You won't want to have it directly on your head node, because you don't want your head node to be bogged down by SQL Server if you're doing a big calculation with. I mean, for example, I was working on a system a few months ago that was a little over 1,100 nodes, and we found that SQL Server was bogging down the head node, and we had to move it off to a separate box.
Why is that? We didn't have HPC that size for 2008, but we have CCS that is 150 nodes or something.
Yeah.
And this is just a SQL Express on head node, and it's fine. So
Well, it depends upon what type of. I guess, are you doing MPI jobs, or are you doing on InfiniBand? Okay. Well, it turns out that a lot of, at least what we saw at this site that I was at, that it was better to have SQL Standard and have it off on a separate system. I mean, but this was 1,100 nodes. 20 to 30 is what I've heard for standard. But that just may be a comfort thing, and for you may just the way you have it set up, you may be working out fine. Right. Their recommendations are not requirements.
Yeah, but it is actually a kind of setback because it requires another kind of server somewhere.
No, you can have SQL running on the head node.
Yeah, but you say that if you bug it down.
No, I'm saying, well, if you're building a large 1,000+ cluster.
No, I'm coming back to the second. You said 20 to 30 nodes.
That's what
So
well.
my size is like 200 to 300, and then
Yeah, and I'm saying that if what you do is fine, if it's working okay for you, that's great. These are just recommendations.
Right, but this is CCS. We upgrade to HPC. It may not work.
Well, no, I'm not saying that it's not going to work. You have to try it out. If it doesn't work, then you load SQL Server. You load SQL Server Standard on the head node. It's not that big a deal, and you're going to have SQL Server in your environment already.
But what data is stored there? Usually the scheduler doesn't have that much data to store and retrieve from any database, and it's just a scheduler.
True. Yeah, I mean, it depends upon. Yeah, I mean, if you.
We have pretty big system, and it's usually all 120 nodes, and you can have usually a couple hundred jobs, some queued, some running.
Scientific jobs, right? Those are running much longer than like financial jobs.
Yeah.
This is what you mean. The
Silos.
silos in the
Yeah.
second.
Yeah. Yes. Yeah. But you do, well, but I guess your jobs are fairly, I used to work with your office, so.
I mean, we have a very long experience with parallel systems, and we essentially pack together these high throughput jobs into MPI system that is just one big job. That's why we don't have these problems. But I can make it. I mean, second generation sequencing, 18 million reads, and it's 18 million jobs immediately. But in this way, there is no system yet that I know that would be not break down. But
How many jobs?
well, it will be then 18 million jobs automatically. Each of them 2 seconds.
Yeah. I mean, most I can ever get to run on a convertible is I can get 8,000 jobs running at once.
So that's why we recommend to all the users that can't submit jobs that just goes to one block, like MPI system or something.
Okay. So we also we have vendor support for different parallel file systems. And there's also some in-memory caching options that you can use. For job scheduling, we have integrated security with Active Directory, so when you run a job, it runs as you. We have batch and interactive and then service-oriented applications, and we're going to be talking about all of those, but specifically we'll be talking some more in depth about the service-oriented applications, the SOA solution we have. We have high availability scheduling, and that we have failover on our head nodes. So you have failover on head node. You can create a second head node. For MPI, we have an MS MPI implementation of MPitch too. We utilize a specialized memory direct. We have what was called memory direct, which gives us faster performance on InfiniBand networks. And our MS MPI has been integrated with Windows Event Tracing, so you can have events go to the event log. So when I was talking about the cluster manager. This is a screenshot of it. So one of the first things you're going to do when you bring up your head node, you get this installed. You're going to configure your network, and you're going to be choosing what type of topology you're going to want to use for your cluster. Then you're going to give it installation credentials, which basically it's going to cache a username and a password that's going to be used to implement the cluster. You're going to set up how you're going to want to name your node. So your node's going to be named node 1 through node 1000, or however you want your nodes to be named. And you're going to create a node template that's going to be used. It's an XML file that's going to be used to create the node. And remember when I said when you want to set up an operating system image, here's where you do that. You create an operating system image. You can add and remove users. You can add compute nodes on the fly. Manage any drivers that you have as far as InfiniBand drivers, all the way down to if you have some sort of specialized hardware, you can do the drivers on that. And up here, you'll see on this side, on this menu, you have this tree view where you can look at your node templates, and this is all just the configuration items that you can set up. You'll see you have node management, job management, diagnostics, and charts and reports, and we'll be going over each of those. So here's the diagnostics view. And you'll see that you have a list of tests that have been run. Some MPI ping pong jobs, some SOA model latency. And you'll see that you have a result, how many nodes it was run, when it was run. And then you have some information that's set up for what the problem was. So we're looking at that one that has a warning, and it says that at least one node is performing poorly relative to the other nodes. So, when you're doing MPI jobs, when one node is not performing as well as the others, that's bad, and that causes an issue. So, these are all tests that are built into the product that allow you to test your IB fabric and test other infrastructure things of your cluster to make sure that it's running appropriately before you put it in production or before you do a top 500 run. Does everybody know what a top 500 run is? Does that mean everybody else that didn't raise their hand doesn't know what a top 500 run is? That's where you have a cluster that you want to submit to the top 500, and that's the top 500 fastest computers, supercomputers in the world. They do it twice a year, and you run a benchmark called LinPack that tests the speed of your supercomputer and the number of well, now we're dealing with petaflops, but it was gigaflops, teraflops, now petaflops. So here's node management. This one I want to talk a little bit about. You look, you've got your nodes, and they appear to be, most of them are all online. One is still starting. But with this, you can take nodes online. You can right-click on one, and you can say take it offline. You can group them. And this works out really well, especially if you're dealing with like I said, that one system that I was helping with, it was 1,142 nodes total, and we grouped all of them into their rack number. So from rack 1 through, I don't remember what the total number of racks were. We set it up that way, and it made it much easier because as we're provisioning them, as you provision something that large, of course you're going to run into issues. Hard drives fail. You run into hardware problems, and then you can say, okay, rack 2, blade number 10, and they could go out with a crash cart and find out what was going on.
On that topic,
yeah.
One problem we have is we number typically our processing number the nodes inside.
Okay.
But when we install this,
Mm-hmm.
there's no provision for being able to say what node is what, right? Even on the startup.
Yeah, you can't. You can set up. Be sure to get one of my cards before you leave. There's a script that you can set up so that you can make sure that that if I name that in rack 1, slot 1 is named node 1-1.
Okay, because like on our big, when we install big like Dell clusters,
Mm-hmm.
we used the USB key and went through,
Yeah.
and was guaranteeing where they were.
Yeah, but there's a script to do. There's a script that I can provide you that will allow you to do that. I don't have it with me today. Believe me, it makes life much easier, and then you can group them by racks, and now if you have a huge system, now you can go through and take care of it. But so other things to look at on here. Whoops. We have We have the health, so and whether a node is reachable or not. So again, like I said, we can group them based on hardware, software, custom attributes. You could also group them. Let's say you're in a situation like at Cornell where you have different clusters for different organizations. You can have, this is for the bioinformatics group. This is for the fracture mechanics group. So you can group, and you can have multiple. Nodes can be in multiple groups. That's the nice thing. So you can pretty much group it based on, you could have a group up there these are machines that have Barcelona chips on them. These are machines that have another chip on them. So, but they could also be in other groups. So it really works out nicely. And you have ways of correlating nodes and jobs together. So you can say, okay, what nodes ran a certain job. You can keep track of long-running operations. You can look at a heat map. There's going to be an example of a heat map. Heat maps are very nice. Basically, it's a way of visually looking at your cluster, and it really comes in handy when you have a large cluster. You'll get alerts for failures. So remember on the previous slide, we had a yellow triangle indicating a warning. You'll get something on the side that says, either there's an error or a warning or everything's successful. So here's a heat map. And with a heat map, you can have up to 3 items that you're tracking. So kind of think of a heat map as sort of like a perfmon, but for a cluster. So you can look at CPU usage. Here we're looking at CPU usage, available physical memory, and network usage. So, and they're each assigned a different color. So you'll see that all these nodes, there's an issue here, but all these nodes are running at 100%. Here's the amount of memory, the physical memory that's on the machine, and what the network utilization is. And then over here, there's something going on. I suspect it's the one that's starting, but who knows? But you'll see. But this is basically a way of saying, all right, I have a lot of machines here. What's not working? And here you can visually see it. But imagine if there were 1,000 on here. They'd be very small, but you would see right away where there was an issue, like here. So, this is kind of a way of looking at, if there were a problem here. I mean, this is so big, you even have the scroll bar active over here, so you can see what the issue is, what machine is down, if there's a problem. So here's a series of jobs that have been run. It's an embarrassingly parallel application, the Asian Options Service. It's one of our samples, one of our demo codes. And you'll see that it ran except for about 5 or 6 items there at the top, and you have warnings. And you can see that they were canceled for some reason. And if we go over here, we see what the error message is canceled during execution, and then there's a couple that are canceled by users. So you can see this is a nice tool that allows you to see what's going on. And we also have charts and reports, so we can, you can look and see what kind of utilization you have for your cluster. A lot of organizations want their clusters to be used all the time. They charge, some organizations charge for the use. They charge their users. So this is a way of being able to keep track of that and look at different parameters, different metrics. So here's some, just some more. So let's talk a little bit about the job scheduler. We can deal with different types of jobs. We have service-oriented jobs, which are primarily what I would call either loosely coupled applications or embarrassingly parallel applications. So, and that's a lot of that is in the financial services area, where you would have Monte Carlo simulations running to determine, to calculate risk, as I used earlier, as example as I used earlier. So those are where your service-oriented HPC applications come from. We have support for job templates. So you can create a job template, and then that's the one that you would use for all of your jobs that you want to run of a certain type. So you create a job template once, and then you just keep reusing that. And we also have interoperability for mixed IT infrastructure. So we have the ability for somebody from in a heterogeneous situation to be able to call our cluster from other operating systems. So, excuse me, I'm going to go close the door. Okay, and we certainly can, with HPC Server, it can help you with your applications, and you can make the best use of multi-core situations. So here we have 2 nodes. They have 4 sockets on each one, and each socket has a quad-core processor in it. So we have the ability that you can tell a job, I want you to run on one node, and I want you to use 3 of the sockets on that node. I want you to run I want you to completely populate an entire node. Or I want you to run on just one processor on a node and use all the cores. So you have that kind of granularity in the scheduler. And, you know, is it locked? Okay. So it, for example, when you do a MPI Run command, you can say num cores, and you can tell it, I want you to go out and use 16 cores and then say num nodes 1. So it's going to know, I'm just going to go run on one machine. So here's the command line, and it's ways that you can submit jobs. You can tell it what node group you want it to use. You have several parameters that you can set up. You can also use a new technology with Windows Server 2008 PowerShell, which is I guess a bash shell type command prompt that allows you to have, like I say, bash shell like commands. Programmatically, you can submit jobs as well. We have an API for both C++ and .NET. We also have a web interface, and we support the Open Group Forum, the HPC Basic Profile.
Yeah, but the HPC profile is kind of limited. I mean, if you use it as a tool to control the cluster, what we do,
Yeah.
it's actually a lot of information that is not in the standard
Mm-hmm.
implementation. Do you have provision to add additional variables to be transmitted?
I don't know.
Without recompiling the whole system. This is what we did with the original HPC, because we were part of testing and
Mm-hmm.
this. So we use it essentially in our portal for biology. So one of the clusters that we use is Athena. But the problem is that we have to add several additional variables transmitted there to just have self-type control.
Okay. I don't know if that is expandable or not. I can find out for you though. But that's not the only game in town. You can command it from scripting or.
If you are, if you have the remote cluster, truly remote cluster behind the firewall somewhere,
Yeah.
then HPC provides the only way that you can
Okay.
control it.
Well,
Unless you cannot.
I'll check and see if that's expandable or not. I talked about Network Direct a few minutes ago, and this is our new RDMA interface for speed and stability for InfiniBand. And if we look at this, before on CCS 2003, we provided this WinSock Direct provider, and that was how the communication was done. And it was done, in along the lines of a hardware driver. So you would write to the WinSock Direct provider, and then eventually it would get down to the networking hardware through the hardware driver, through the hardware manufacturer's driver. With Network Direct, you make calls into the Network Direct driver, and it goes through kernel mode bypass, and it goes directly to the network hardware. So we find that this is working out very well. We're getting good. We're getting low latency, good throughput, and the Open Fabrics driver for Windows includes support for Network Direct, WinSock Direct, and IP over IB protocols. So you can still use the Network Direct if you want, but WinSock, but you also have this new Network Direct provider in the new version that works quite well. So with Windows Compute Cluster 2003, you can see that in the spring of 2006, we were the fastest machine that ran on Microsoft technology was 130. It had 897 cores, and we got 4.1 teraflops out of it. In spring 2007, we were at 106 with 2,048 cores, 9 teraflops. And then something that we're really tracking also is efficiency, so over 58.8% efficiency. This last, a year ago in the fall, last year, even though we had a better efficiency improvement and we got faster teraflops, we fell to number 116. Okay. But we had 77.1% efficiency, which is pretty good. And then in the spring of this year, we were at number 100. And it had 2,096 cores, 18.8 teraflops, and was a 76.5 efficiency. And then all the way up to, we got to be number 23 in the spring list. On a cluster at NCSA, it had 9472 cores. It was a 68.5 teraflops. It was 77.7% efficiency. And that same machine running Linux, the exact same cluster running Linux, its teraflops were, I'm not sure the number, it was lower, I know, but its efficiency was like 60, I think it was 67.7. I think it was around 10% less efficient. We got to be number 10 this year at just at the supercomputing conference last month, and the Shanghai Supercomputer Center. And you can see what it's running, Opteron 1.9 gigahertz, has InfiniBand, it's running HPC Server 2008, and we got to be 10. We was very close with the number 11 system, but we got into the top 10. Here's some comments from some of our customers. From Boeing, from Ferrari, and from Procter and Gamble. So we're working across different organizations, different technologies, different manufacturing, aerospace, consumer products. That's kind of, how many people 10 years ago would have, when they were thinking about supercomputers, would have thought Procter and Gamble, the people that make, Crest. I think it's like Crest, Crest toothpaste. But, all of these companies are finding that they can use supercomputing or high-performance computing to do different organizational things that they have to do. Now, Procter and Gamble probably, I'm sure they have some chemists and things to test, but they probably also use clusters to track their finances, their stock. So, and of course, Boeing and Ferrari use them for different, for engineering purposes. Did anybody here go to supercomputing this year? Did you see the Cray box that was? I think it was actually our giveaway in our booth. It's a nice little box, isn't it? It's I don't know, maybe a meter a meter long and 10 inches wide, and I think it has 64 cores in it, and I believe it may be around $50,000, which, you know, if anybody would have said, you know, 10 years ago that you could get a Cray in your office for, you know, under $1 million, they would have been surprised. So this is kind of an exciting product. HP also has a portable cluster. I've worked with their portable cluster. It's quite nice. And also with, like I said, Nortec, a company in Minneapolis. They have some really interesting portable clusters and some interesting containers. They also they produce a machine that can sit in a jungle in 100% humidity and run. It's pretty amazing. So we provide tools to help you port Unix applications. We have a Windows subsystem for Unix, which basically allows you to run Unix commands at a command shell. There's also Visual Studio extensions for debugging POSIX applications. And also we provide support for both 32 and 64-bit applications. Now, this is something I probably should have mentioned earlier. This is only a 64-bit operating system. There is not a 32-bit HPC server. It's 64-bit only. We recently ported a WRF weather model. It was 350,000 lines of Fortran and C with MPI OpenMP. There were fewer than 750 lines that were changed in makefiles and scripts. And the level of effort was similar to port to any new version of Unix. And we were able to get performance that was the same as on a Linux system. And Microsoft has what we call the India Operability Lab at the MTC in Bangalore. And they're set up to help people if somebody needs help converting a Linux application or a Unix application to Windows. They're there as a support mechanism. So as far as Visual Studio goes and how Visual Studio helps you perform HPC applications, all three of our main languages, C++, C#, and VB, are supported for HPC applications. We have a new language. Is everybody familiar with F#? Okay. There's a slide later on F#. F#'s a functional language. It's becoming very popular in the financial services area. We also have support for Python, Ruby, and Fortran. If you get the Intel or the Portland Group's Fortran compilers, they basically plug into Visual Studio. And then we also support OpenMP and an MPI. For team development, has anybody here used the Team Suite version of Visual Studio? So you've used the code repository and assigning tasks. I mean, this is more of an enterprise application or enterprise development environment type system. But basically, you can say, okay, we have all these tasks that have to be done, and you can assign them to different people. And then there's also bug tracking. You can have integrated tests and cover code performance, code profiling. I mean, we're probably all of us are familiar with the IDE. It's a nice IDE, works great. We have a parallel debugger now. We allow for multi-processor builds, and you can have drag and drop workflow design. In the .NET framework, we have this new technology in the latest release called LINQ. It's a language integrated query. It allows you to do SQL type queries on any kind of a data store, so you could do it on an XML file, or you could do it on a flat file. So it basically allows you to have a select something from something where there's some parameter. And all the rest of the goodies that you get with .NET. There's an MPI.NET that was released with this version of the HPC server. So now there's a .NET binding for MPI, so you can run C# MPI. And some different computing technologies. If we look at, over here you have local computing. So if you think about, here's some examples, or like a robotics manufacturing line. Is everybody familiar with Silverlight here? Silverlight is our Flash-like GUI. It sits on top of WPF, Windows Presentation Foundation, and all of the. If anybody went to like MSNBC.com during the Olympics to watch Olympic events, that was all run through Silverlight. And again, so if you come down here, where up there you kind of have task concurrency, down here you have data parallelism. So here's some examples. And then out here you have distributed and cloud computing. Internet-based photo services. So Kodak has where you can go off and order prints. They're in a sense, if they had a cluster back there to do the image processing to generate all these, they certainly have a distributed system of some sort. And then, enterprise search, live, live.com. Animation and CGI rendering. So, when you're generating movies, weather forecasting, oil exploration. Down here is sort of your very beefy, requires parallel, some sort of parallel data and some sort of distributed computing. Whereas up there, it's more, providing immediate information. This is very much kind of beefy operation. So if we look at some of the technologies, so down here we have cluster SOA, cluster P-Link. We'll be looking at P-Link. That's parallel link. That's part of our parallel extensions. But over here we have MPI, Windows Communication Foundation, which we'll also be talking about. So over here is more, certainly up here more traditional. Down here getting to be a little bit more of a parallel type operation. OpenMP is kind of MPI, where a shared memory implementation of MPI. Whereas now over here you're getting to be more of a distributed and web-based world. So here's a Monte Carlo simulation running in Excel. And what's going on behind the scenes here is it's setting up basically a web service call to go out and gather the information that's being calculated out on the nodes. So we have Excel. It makes a call out to the head node and WCF broker. It'll set up the WCF broker. It'll pass back that information, and then it will make calls through the WCF broker to the compute nodes, get the information, and it comes back. And here's a kind of a look at the code. I don't know if kind of the key is a session. Session creates session. And then it does a new service client, and that's the WCF Windows Communication Foundation call. And then it basically begin price agent it makes this call. This is an asynchronous call to the cluster. And then it just basically gathers the results. So at some point down here, when it makes the call, this has, and I need to rewrite this so that it's using an inline callback. So this is when this call finishes, this code gets called. It calls end agent price option and end price agent options. So that's the matching async call to this. It pulls the information out, populates it, and then it's done. Normally, the callback code, where is it down here? The callback, that's in a separate function. I think they might have done it this way for just to have it all on one page, but it's probably not the best way to write that code. And there's where the code gets called, and if it's not on a cluster. And if it is on the cluster, then this is what gets called and gets returned. And this just sets up, as I explained, this just sets up. So what's the broker performance like? Well, as you can see on, you can see the colors pretty well on that. On Gigi, it does pretty well. Latency is good. On IP over IB, a little better. And on WSD, it's quite good. And then we get higher throughput. So if we look at different sizes of ping-ponging, so 0K ping-pong, of course, we get the fastest throughput. Even with 16K, we get pretty good throughput. So just some benchmarking. I mentioned MPI.NET a few minutes ago, and it supports all of our .NET languages, even Visual Basic. So I don't know if there's any Visual Basic programmers in the room. Okay. But is everybody here familiar with MPI? I would imagine. So if you look at this, this code just makes sense. If world.rank equals 0, you send hello world, and then you receive it. So it is MPI for .NET, and that's, there's not much more to say about it other than that. And as I said, that we have different add-ins that can be brought into Visual Studio from different vendors. Here's an example of a parallel debugger. Now let's talk about parallel extensions. Has anybody here heard of the parallel extensions yet? Okay. This basically allows you to take advantage of multi-core development. So I mentioned p-link earlier. Here's p-link. So from n in names as parallel, where n.name equals some value, state equals some value, year. I mean, very, very SQL-like syntax. Order by and then select n. And you're going to get a value that's returned. Now, the nice thing about this is, if you were going to do, let's say, a traditional link call and not do it as parallel, you would have to implement. You'd have to manage the threads. You'd have to implement take care of all the parallelism on your own. With this, it handles it for you automatically. It automatically says, okay, I'm going to go off and run, and I'm going to generate the threads and generate what's necessary to run on the different cores that are available to me. And we have the same thing here. We have a parallel 4. So traditionally, if we were going to do some sort of a 4, we would have to have the asynchronous call in here, and asynchronous code again is not as easy as writing synchronous code. So here all we do is just add a keyword parallel.4, and now this will get spun out into your different cores. What here? No. This would be if this were a calculation, it would. Yes. Yes. No, it would. Well, let me say.
You implement dgen in that, right?
Yeah.
And it would parallelize that, or does it make separate function calls?
Well, it will make it. This example has a separate function call, but if I were to have a computation here, it would handle the computation in parallel.
So it would break up and
Whatever happens in here gets farmed out, is what I'm trying to say. Whatever happens in between the brackets.
Okay. I'm trying to understand the data. The data is being distributed and worked on, basically.
Yeah.
Let's say you did a matrix multiply.
Okay.
Would it break apart that matrix multiply?
If the data was inside the loop,
yeah,
it would.
So it just looked at the index and looked at the divided by the end.
Yes, but if you were doing something, like if you were doing something with a parallel file system, for example, or if you were doing something that was not necessarily standard, I don't know if it would handle it well. Like if you were using some sort of a third-party call.
I'm just thinking of just
being
data parallel. That's all.
Yeah. As long as the data is contained in here and it can get at the data, it will pull the data out and do the calculation on it.
Here it means that it can be. I mean, I understand that it assumes that it's on one node. Yes? It's only multi-core. It's not multi-node.
Yeah.
In this example, it's multi-core. Yes.
But can it be multi-node? I mean, my question is does it assume that
You're getting ahead. There's a cluster.
Okay.
A cluster 4.
This is shared memory, so whatever is
Yeah.
the computer will be actually.
Yeah.
So basically what I'm saying is if you could implement a BLAS routine this way, it would parallelize that.
Yes, I believe that it would. This is good. I probably need to come up with a better example that does do something other than just a method call.
Distributed type computing and not parallel.
Yeah. But no, it is true. It will take the data and it will do the calculation. It'll assign a core to it and have the calculation done and do it in parallel.
Essentially, you can also have result of I equals compute of I, comma, result of some, data, something of the other kind of. So any data is accessible, not only the parallel.
Well, no. I mean,
I know that you can.
if are you asking, will it take the compute from a previous?
No, that I know.
No. Yeah, that's MPI.
What I ask is that this example suggests that the data needs to be also parallelized. While you can access different types of data at the same time, some of this data is actually in the matrix, some of this is out of the matrix.
Yeah.
So is it possible or just?
Yes, it's possible. Yes, it will take the data. So let's say we had a matrix here. It would take that data, move and pass it to the parallel routine that's going to do the calculation and get the results for whatever the data is. Now, that's, again, like I said, if, let's say, the third and the fifth have to have data for each other, that's not going to work because it's not MPI. Yes.
What are you doing in this e-link? This is going to SQL
This happens to be I know the demo that this came from, and yes, it's actually going to SQL.
So you're asking SQL to do what it does in parallel?
No, what's happening under the hood is that there are now parallel calls to SQL.
But wouldn't SQL parallelize, do multiple threads on a query you give it anyway?
Well, yes, but the thing about this is this doesn't have to be SQL. This can be data from any source. This could be XML data, and it would go off and get it in parallel. There are a number, I mean, if you're interested in P-Link, there's actually a number of good books that I can suggest to you on it. It's a really nice technology. So here's kind of an example of sequentially, we're basically walking a tree. So we process a node, we make sequential calls and do something. And here's how you can do it with a thread pool. You got to do a wait callback. I mean, the delegate. You know, this is when I was talking about parallel development being hard. This is what I meant. I mean, you've got to do all this plumbing stuff on your own. And parallel extensions with using a task. We can set up a task. We can create a task. We give it a delegate, have it run, and then wait. If we do parallel extensions and just do it parallel, we can just do a parallel do. And then we have this, these are lambda functions. And you basically make these calls and they happen in parallel. Or you can do P-Link, and you can just do a tree as parallel for all in action, and everything that's in this action gets done in parallel. So you go from this, yeah, a little easier. Still got to know about how to deal with some of our synchronization technologies, to something that's quite a bit easier, to one line of code.
One line of code is that easy because you are doing with the trees and you have predefined function for the tree.
Yeah. Well, okay. So F#, I mentioned earlier, it's a functional language, object-oriented. Like I said, it's becoming somewhat popular in the financial services area. It's a language that grew out of Microsoft Research in Cambridge, England. And with the next release of Visual Studio, it will be a full-fledged product, full-fledged language in the product. You can get it now, download it, and install it into Visual Studio. A lot of people like it. My jury at least is still out on it. I like it sometimes, and there's other times that it kind of confuses me in how it works. But it is a nice language, and that I guess that one of the advantages of it is that it helps avoid mistakes, in the sense that when you're writing code, everything you do is immutable. So you can't really stomp on your results in any way. And I guess that certainly makes debugging easier, and will eliminate a lot of mistakes in the coding process versus having to debug it. Has anybody here done anything with F#? Yeah. I don't see a lot of people using it for MPI jobs, but for embarrassingly parallel, it's pretty popular. It's like if I set I equals to 10, I will essentially I is always 10. And I haven't, it's one of those things where when I started out programming in Fortran, Pascal, and then C, it was before object-oriented programming became popular. And then when I went to do object-oriented programming with C++, I kind of had to shift my thinking a little bit. This is, again, it's a paradigm shift. And I haven't quite shifted my thinking around it to where I'm like, yeah, I understand what this is trying to do, and yes, it's good. I mean, if I keep playing with it, at some point that will happen, or my thinking will shift, and I'll think it'd be quicker for me to do it in C#. So with F#, you can do a lot of your development in an interactive shell, and the interesting thing about the interactive shell is that it is kind of like, if you remember the old. I'm kind of dating myself, but old basic compilers, you type in a line and it would interpret the line right there and tell you what errors you had. It's kind of how this works. So you type in your program live, and it tells you whether or not everything is okay. If anybody wants more information on this, I'll send it out to you. Here's just some examples of how it's dealing with asynchronous code. So, does anybody here use GPUs to offload any of their calculations? Okay. Oh, great. And what? Cells. Oh, okay. Where are you from? Oh, local guy. Okay. So we certainly are supporting GPUs as a way of doing more calculations. So, of course, with Microsoft, we have our own technology. We have DirectX. AMD has their GPUs, NVIDIA, Intel, and even Apple has some ways of utilizing their processors. And ours is DirectX 11 Compute Shader. It integrates with Direct3D. We have more data structures available, and more algorithms, general algorithms available. We support image post-processing. We have different physics effects that we can utilize. It supports ray tracing. You can also it supports gameplay physics and AI. So I wish I had some samples of this to show you, because these are kind of the whiz-bang samples that get people excited, but I don't. I mean, this is something that I'm sure you'd probably be interested in, I would imagine. And here's an FFT performance example. So doing a 1K by 1K 2D FFT. Doing it in software, we did it in 42 milliseconds at 6 gigaflops. Using Direct3D9, it ran in 15, that's our older DirectX, it ran in 15 milliseconds, and we got 17 gigaflops, so it's a 3x improvement. Using CUFFT, 8 milliseconds, 32 gigaflops, that's a 5x improvement. Using our prototype of DirectX 11, we got 6 milliseconds, 42 gigaflops, which is a 6x improvement. And then doing, I'm not sure about what the latest chips means. But I guess on the latest chipsets that we're getting 100 gigaflops. So, these are certainly we're seeing a lot of our customers that are coming to us asking us to have more support for GPU offloading calculations to make that and when you say that, it isn't necessarily that they want us to write the code inside the system to do that. They just want us to make it easier for them to utilize existing libraries. The IMSL has a .NET numerical library that's available in Visual Studio. So let's talk a little bit about SQL Server. Who here uses SQL Server? What do you use to gather your data? Yeah. Oracle. Okay. You didn't raise your hand. I know you use SQL Server. Yeah.
Oh, yeah, I did.
Yes. Oh, okay. Yeah. Okay. Okay. So, with SQL Server, you get these different functionality, different add-ins to it, integration services, analysis services, and reporting services. So that if you want to build a data warehouse, you can, and you can certainly generate any kind of reports that you want. And fully, HPC, of course, fully integrates with it, as well as through SQL Server, you fully integrated in with Office and its different products. So here are some examples of things that you can create out of Excel. Going to SQL Server and visualizing your data. So these are different charts that you can create, different graphs. The same thing with data mining. You can pull out information into spreadsheets. And there's algorithms available. There's neural-net. There's Bayesian. There's time series. All these guys are available inside SQL reporting to allow you to gather data and produce reports inside Excel. Who's familiar with Workflow Foundation? So Workflow Foundation is one of the pillars of .NET 3, and it allows you to graphically create a workflow. And people that have been developers for years have written workflows, and it seems like a lot of times that's all we're doing is we're writing workflows. Well, this is a way of having a workflow generate. Basically, the plumbing of the workflow is done for you. You just have to add in your custom code and what you want done. And this is inside SharePoint. You can also do it external to SharePoint if you want. And if for whatever reason you have a workflow that is we'll do calculating risk. You have different steps that you want to have taken. You can set that up so that different simulations are run at certain times, using data from one simulation into another. And we have this nice graphical tool that allows you to drag and drop different items, and you double click on it and type in your code.
How does this run outside of SharePoint?
It's .NET. It's .NET 3.0, so it's already built into the operating system. So it'll run as an executable. So I mean, you can have it as part of in SharePoint. It's part of the SharePoint MOS. It's part of Microsoft Office SharePoint system. So it's part of the larger SharePoint product. But you can also do it externally. You don't have to have SharePoint to do it. So with the University of Washington, Microsoft has generated, we have this thing, the Computational Finance Lab. And it's sort of the computational finance version of the Computational Biology Service Unit. You input some data and they email you back a result.
So we are actually, there will be a talk Tuesday. We are doing actually because what you talk is not CBS, it's bio HPC.
Yeah.
So we
Well, sorry.
No.
We used to work together at Cornell, and I worked at Cornell before I came to Microsoft, so they've changed things a little bit since I was there, but that's the old name. Well, we'll just call it Computational Biology Classic, right?
No, CBSU is the unit.
Yeah, okay.
BioHPC is the product.
The BioHPC is the product, okay. So basically, it sits on SharePoint, and if any of you are familiar with SharePoint, this is kind of a SharePoint, portal view, and you can input data. You can, different models. You can add. You can run your calculations, and you get your results back. And when your results come back, you come back in an email, and then you can click on that, and you will see your results in an Excel spreadsheet. There. So that's just kind of showing how we're working with the University of Washington to utilize HPC in a way that let's say we had your mom who doesn't know anything about HPC. She has this spreadsheet at home. She types in some values. She hits a go button. And then she gets an email back 5 minutes later and clicks on that, and it brings up this Excel spreadsheet that gives her some numbers that she can utilize to decide what to invest in. It's HPC for the masses. So, and you can look at the results in different ways. Look at graphs, charts. So. The goal of this product and of Microsoft is to allow anybody who wants to do HPC programming to do it in an easy, straightforward fashion. Like I mentioned earlier, buying a couple of servers, sticking them under your desk, and you have your own small little cluster. It's affordable. It works well if you're familiar with doing any kind of Windows infrastructure work or administration. It's going to be a no-brainer to pick it up. For anybody else that's new to Windows, it's certainly easy enough to figure out, and there are plenty of books on the market that allow you to administer server. Like I said, it's just at its core, it's Windows Server 2008. With the HPC pack on top of it. So when you first install it, when you install your head node, which is really the only node that you actually really kind of have to physically touch, the first thing you install is server, then you install the HPC pack. And then the rest of it is just through that cluster manager. So any questions? Yes? Oh, I'm supposed to give you this because this is being recorded. That way they can hear it.
Thank you. My first question is just a very, very simple question, and I was wondering if this presentation is available on the Microsoft website.
I will check. I have a stack of cards here. Please as you're leaving, please take one of my cards and email me a request, and I will see if I can give you this.
Okay, that sounds good. My other question was actually about the workflows.
Sure.
Because, I'm just interested in finding out what tools and technologies Microsoft might have to graphically design a workflow and just submit it to the cluster.
Okay. What you can do, it isn't as straightforward as it eventually will be, but for right now, what you would do is you would create. Are you familiar with creating a workflow in Visual Studio?
I have created a workflow in the designer.
Mm-hmm. So what you would do is you would create that, but you're going to have to create it as a service. And then, if you remember, if we go back, Great. If you remember this one, when all these guys get moved over and get populated out, that's the workflow that you're going to want to have pushed out. In order to do that, it has to be a service. It has to be created as a service. Well, more specifically, it has to be created as a. No, it just has to be a service. So what you're going to want to do is when you create, you're going to create a service, and then inside that you're going to create a workflow. And then you basically create that workflow so that it works independently, however you want it to work. You add your code, and then it gets pushed out via the scheduler, and you're good to go. So it's just one more step. You have to create it as a service. Any more questions?
This Excel example, is this based upon the one that's on the website?
What's the one that's on? Is it the Asian option demo? It's on the website.
No, I don't think so.
Well, it should be. They should all be. They all work. All the examples I've seen have worked the same way.
That actually had a user-defined function and saved out the Excel file, so you need to have file share working.
You don't have to have file share. That sample used file share.
Oh, okay. Because it explains it as needing file share.
That example needed file share, not that it needed it. Not in general, no.
Okay, so just clarification on something you said earlier. Well, so I understand how we're going to be using some services to upload a workflow. I was just wondering if how this technology might be simplified in the future, or what to expect.
What would be nice, and what I would like to see, and I'm not. This isn't saying that this is going to happen. But what I would like to see would be I create anything, a workflow, an Excel spreadsheet, and one of my options is send a cluster. And it automatically packages it up in a way. So when I develop, I'm developing knowing that it's going to be HPC, but I don't have to specifically do any HPC-like things to it. I just press a button in the IDE, and it packages it in the like an MSI file. When you create an MSI file, this creates a cluster file that knows how to go out and populate it knows how to get itself populated out there. I mean, this is all stuff that I'm pretty sure they're working on. So, I mean, I know that I've talked to people that have said, I really would love it when I do all with using Visto and Excel, Visual Studio Tools for Office. It would be nice that when I do all that, I can just go, run as a cluster or run as an HPC job. They're like, if we could do that, we'd be happy. And this is all stuff that's been fed back to the product teams. I mean, the thing is that when Excel was written, when WPF or WF was written, this wasn't this product was just a dream. Now it's real. Now we're finding, okay, because we have this functionality, now we're pushing extra functionality inside Office. Any more?
One of the questions, you said it runs as a user on the worker node. It runs as you.
Yes.
One of the questions I had was, as you want to bring up the user's environment on that side, but it seems like it takes a long time to get that initiated, like mounting external directories, home directories, and all this other stuff. Is there a better way around that?
Okay. The question is, when a job is run, it runs as the submitter, and it takes a long time to generate their environment, like the shares that they have or the different mounting settings.
In many cases, it doesn't generate more, or it doesn't generate.
Yeah.
Well, we want to try to get a consistent environment. That's the thing, right? It's not
All
like
right.
we're in a business situation where an IT department putting together an application. I want to eventually have end users putting this stuff out there.
Okay.
And going down that path means I have to have a consistent environment.
Well,
Because that's what we
Yeah.
have on our Linux clusters, right? When I look at Apple.
yeah. So I mean, on your Linux cluster, does their .login profile gets moved over?
They're all mounted. Everything's mounted the same.
Okay.
If you have a Linux system, you have it system-wide. I mean, usually you have all the shares mounted for the whole system, for the user. On Windows, you have P drive that may be either system-wide or the user-defined.
Yeah.
And most of them are user-defined. This one will not be recreated, so the solution is to create system-wide mount, like a service. If you want to have H drive everywhere across every button, then you define a service that mounts H drive for the system whenever it boots. And then
So
it's
now it's
a
everybody's directory. all
Yeah.
I mean, that depends what you want. This is just a service.
Yeah.
We have a service like that written in Perl. And it runs and it works. But this is just, we have been talking to Microsoft for ages to actually make it happen in kind of system solution.
Yeah.
And so far I never seen it.
Yeah. I'll be honest. I'll have to check into this, and I guess, and I have to repeat the question again. The question is how can we make sure that the user's environment goes along with their credentials? And I mean, I think that there's probably ways that you can script it to have it done, but it's going to take time once it gets to that node, to actually replicate itself. I don't know if there's a way around that. Any more? All right, well, thank you very much. I appreciate taking time to come and listen to me. And please, everybody, take a card, and if you have any questions, please feel free to email me, and I will try to get you an answer as soon as possible. Thank you.